inside each one of us. And it's right at the source and base of mind, right at the source of thought, and it's also at the source of all matter. There is no matter as such. All matter originates and exists only by virtue of a force which brings the particle of an atom to vibration and holds this most minute solar system of the atom together. We must assume behind this force the existence of a conscious and intelligent mind. This mind is the matrix of all matter.
Max Planck is very exists.
The validity of the word is totally immutable. As a fixed thing that you can feel and touch, your body is also reassuringly solid. But we knew without doubt, one Philip was assured us that the validity is a mirage. All physical matter, everything we have around us, is the result of a frequency. And what that also means is that if you amplify the frequency, the structure of the matter will change.
He's talking about the frequency changes. Actually, recently, the last decade, they thought that everything and all types of quantum mechanics, particles, it is just a mere vibrational strings. It is, they propose that this theory is the theory of everything. As we know, that in the 20th century, scientists tried to summarize all the energies and forces in nature into four types: the gravity and the the second is the electromagnetic force, the third is strong nuclear force, and the fourth is the weak nuclear force. Now they try to merge these four forces into one single equation, that we can take all the equations of nature from this single equation. There is some candidate for this theory, the string theory. It try to understand the different particles with different features, electrons, neutrons, quarks, the spin of these particles, the strangeness, the charge, by just a vibrating string in 11 dimensions, not just in these 4 dimensions. So they think that there is some hidden dimensions, but still they understand this as a material hidden dimension.
Imagine a universe where time moves forwards and backwards, where you can be in 2 places at the same time, where simply looking at something changes everything. Imagine a universe where you create the reality you experience. Now, imagine that you are there in that very strange universe, because the truth is, you are. You create the reality. Welcome to the observer effect.
If you want to see fear in a quantum physicist's eyes, just mention the words, the measurement problem. The measurement problem is this: an atom only appears in a particular place if you measure it. In other words, an atom is spread out all over the place until a conscious observer decides to look at it. So the act of measurement or observation creates the entire universe.
Imagine a universe.
This is a big problem in science for the last 50 years. The behavior of all particles will try to make the decision just by when you observe, when a conscious being observes. It will try to move everywhere, every possible way. Just it will collapse into one of the ways by just a probability equation, and they don't know why. Maybe there's some free will for the electron that they choose this and not that. So maybe it's correlated with the free will of our conscious mind. Here there is some brilliant scientist. It's Richard Feynman. He's a Nobel laureate in theoretical physics. He will describe the motion of the electron, how it can conceive the best way to move. Even if you don't know what is the best way, just by trying all the ways, it will try to use the best way, even that it not know the which what is the best. So just see for a few minutes. This is a real lecture. This is a real lecture in 1963 in Cornell University.
From one place to another, you do it in class. You calculate a certain quantity, or you invent a possible motion that gets from one given place to some other place that you're interested in a given amount of time. Say you want to go from here to here in an hour, and you want to know by what route you can get from there to there in an hour. By what curve? So what you do is you calculate a quantity getting the curve. If you try this curve, you calculate a certain number for this quantity. I don't want to say what the quantity is, but for those who have heard of these terms, this quantity on this route is the average of the difference between the kinetic and potential energy. Now, if you calculate this quantity for this route and for another route, you'll get, of course, different numbers for the answer. But there's one route which gives the least possible number for that. And that's the route that the particle takes. Now we're describing the actual motion of the ellipse. By saying something about the whole curve, we've lost the idea. Now we're describing the actual motion of the ellipse. By saying something about the whole curve, we've lost the idea of causality. Like a particle here, which means the curve, which means the vehicle. Instead of that, in some grand fashion, it smells all the curves around here, all the particles, and decides which one to take. This is an example of the wide range of beautiful ways of describing nature. And that when people talk that nature must have causality, well, you could talk about it this way. Nature must be stated in terms of a minimum principle. Well, you could talk about it this way. Nature must have a local field. Well, you could do that.
Interestingly, the undergraduate courses of this scientist for 2 years is recorded on videotapes, actually audio videotapes, and it was summarized by physicists to 4 books, self-teaching. It is a very famous, and maybe 1.5 million books were going to be sold for the last 40 years. The Feynman lectures on physics for interested. And these lectures you can see here in the website. There is some project for Microsoft. The kids put it online for free of charge on this link. 7 lectures from messaging lectures.